Good evening, everybody. For those who don't know me, I am Cassie Hart, the founder of Quilibrium Inc. and one of the main builders of the Quilibrium protocol. For those who are tuning in for the first time, welcome. Kind of surprised you're here, but cool if you are. For those who have previously attended other streams, this is going to be a little bit of a departure from our previous dev talks because there's been a few things that have been occurring in the Quilibrium community, and I want to address them, and then we're going to dive into a few topics around it and some important questions that folks want to have answered, and we'll also have a little bit of Q&A at the end. So thanks for showing up, and we'll go ahead and get started. And yeah, of course, like always, I pop open Excalibur. That's actually not going to be the start of it this time. This time, State of the Union. Couple quick disclaimers. Something that people might not necessarily be aware of because they've come into this project from a few different sources. Since this is a relatively small crew that's building this project, it's not too surprising that information sometimes gets a little hard to find. We do have info at quilibrium.com and also our discourse, not Discord, discourse at discourse.quilibrium.com. Please view those and participate in open discussions. I try to be active as much on there as possible, and I'm also very active on Warpcast because I do also work for the Farcaster team. So, disclaimers. This protocol is under active development. A lot of the topics today will be developer-focused. I'll try as hard as I can to keep them as not as deep in the cryptographic weeds as possible, but there will be some things that will get, unfortunately, deeply cryptographic. I will try my best to explain it in as plain terms as possible. So, other than that, the protocol is in adherence to a fair launch principle. It is a utility token. We do not condone, encourage, or discuss the token in any context outside of this purpose and strongly discourage others from doing the same. So if there are any questions related to that on any other topic outside of its uses of a utility token, we will not acknowledge or answer those questions. If you are running a node alongside that information, please do so with the understanding of the above statements in mind. So today, our agenda, we're going to give a little bit of an intro into the project for people who are not as familiar and talk about our mission. Talk about the history that led to what Quilibrium is today. Do an architectural deep dive and talk through the components of the architecture because it will be very important in talking about our 2.0 rollout, what happened, when 2.0, and what changes have occurred and are occurring to get 2.0 out the door. And then finally, we'll, yes, cryptographic content, adult supervision advised. Yeah, very accurate. We'll also end this out with a Q&A. So, to get started, principally, the internet is under a multi-sided attack. We've seen things like the recent indictment of the founder of Telegram. We've seen incidents in the past where the FBI has pressured Apple into dropping end-to-end encryption, people being deplatformed, entire infrastructure as a service, services like AWS pulling people off of their platform. This is a multi-pronged attack on the web today. And what's problematic is these attacks come from so many different angles. It comes from those who provide our identity, personal storage, communication, ISPs, cloud providers, and of course, governmental pressures. At this point, when I was saying this, when I started, talking publicly about this project years ago, people thought that was a little bit conspiratorially minded, but nowadays I feel like more and more people are starting to actually see the mask come off from all of these and realizing how true this is and how serious of a problem this is and how little time we have left before this problem is no longer able to be solved and the door will be forever shut at trying to solve it, which is why we are in such a hurry to get to a solution today. The current era of crypto is very ineffective to fight this, and the little animation kind of illustrates that factor. The linearization of all content into singular blocks of transactions with execution caps really only succeeds at producing limited financialized applications. It can't reach out to internet scale applications. Just to give you a very simple example of this, the greatest TPS or transaction per second network, if you were to include all of the voting transactions as actual transactions, is only sitting around 7,000 TPS. And iMessage, for example, in 2016, and it's grown way beyond that since then, is at a rate of 200,000 messages a second. There is no crypto network out there that is under a blockchain-oriented protocol that can effectively provide internet scale applications. It always leads to something that has to occur off-chain with some tiny on-chain component like identity, and very frequently, by consequence, results in very financialized problems, like things like limited namespaces become bidding wars. You end up with conversations around like Harburger tax. It ends up in a way that people don't feel like it's actually usable, and which is why we end up with these situations where people say it's actually a solution in search of a problem. But we have an alternative thesis. There are ways we can leverage the research that has come from crypto in order to provide... Oh, my voice is too quiet? Let me see if I can increase the volume real quick. I'm not sure I can. Let me see if I can fix that real quick. I'm sorry. Yeah, I don't see any way I can increase the volume on this, so I'm sorry. I'll try and boost the audio in the recording when I publish to YouTube. But anyway, back to the point, our core principle is to use the research that's come from crypto because there's been so much innovation in the space, and a lot of it is only in paper form. There's a lot of a lot of really powerful ideas that have come about from all the research that's happened, and it hasn't all been put into actual use yet, or in the ways that it's been put into use, hasn't been used very effectively. And I've talked about this a lot. But today we're going to talk about those pieces, how they fit together, and also a few things that we're going to have to tweak to make it all fit together in a way that works best for everyone. So, core to the point, our mission is to become the base fabric of the internet that secures every bit of traffic over the web. That's an ambitious mission. One particular investor I admire dearly actually referred to it as Herculean. But I believe it's possible. And the reason I believe it's possible is because I have been working in this space practically from the beginning. I was on the MetStowed mailing list when the infamous Satoshi Nakamoto showed up to post the Bitcoin white paper. I have been a very strong cypherpunk individual for practically my entire life. I have seen so much that has been done and achieved in this research, in the actual protocols that have been developed, and also things outside of the crypto space that can be combined together to create powerful tools. And I think that that is something that Quilibrium can do. So a little bit of history. All of this actually started because several years ago, 7 at this point, I'm starting to feel very, very old, I was actually getting really disappointed in Discord, of all things. Discord was starting to get really popular, and by consequence, they were starting to get a lot of media attention about things that, like certain communities that were starting to onboard onto Discord, and they had their own cultural terms that maybe were not necessarily cool with everyone, and it was starting to get enough media attention that Discord was getting heavy-handed with banning people. And then there were talks about potentially Microsoft acquiring Discord. These things started to lead to a concern that we needed a... I will try my best to speak a little bit louder. Anyway, it got to the point where it was becoming very clear that, Discord was heading down a path where freedom of speech was not something that they were actually condoning. And to me, I'm a very strict constitutionalist. I actually see intrinsic value in freedom of speech. I've seen how valuable it is. There's a person I deeply, deeply admire who has done a great deal of effort by leveraging his simple ability to sit down with people and talk with people to change their minds on some of the worst possible beliefs a person can have. And so from that point of view, I feel that providing a tool that enables people to speak freely is the greatest tool for actually achieving progress in society. So I set out with this plan. I had been running an educational stream where I was teaching people how to code, starting from simple principles and building all the way up to actual full-blown applications. How do you build things at the scale of Facebook? How do you build things at the scale of Apple? And so I created a Discord clone. And in doing so, I realized if I wanted to launch this, I am actually now facing many demons. The first is that when you release an application, say for example on iOS or on Android, you have to deal with App Store policies. App Store policies are actually quite strict and very anti-free speech. They have things like reporting, which you have to adhere to. You have to handle user reports, and that can be an understandable thing, and there can be ways you can actually work with that and still maintain free speech in a general construct. But at the end of the day, if there is too much political inconvenience, you will still find yourself deplatformed. And very similarly with Amazon Web Services or any of the other cloud providers, if you are politically inconvenient, they will deplatform you as well. So I realized, I'm facing actually a much bigger problem. If I'm wanting to actually solve the problem of promoting freedom of speech and privacy on the web, I actually need to solve the real problem of freedom of speech and privacy on the web. How do I do that? And so from there, I started to pivot into how do I decentralize the web services that people rely on day to day. And this is an old screenshot from many years ago where I had created the first iteration of what is now today Quilibrium. And it had a lot of very, very out there ideas. Definitely not to mention the 30% fee on all transactions. I really, really hope that Epic finally gets their way through. I know that the EU finally had that breakthrough, and Apple now has to allow alternative app stores, but they're still kicking and screaming and doing all sorts of petty things to try to stop that. But anyway, a few years ago, I created the first iteration of what Quilibrium is. And it was very ambitious. It was very novel on a lot of different cryptographic constructs. I was deep in the weeds so far that I was coming up with different kinds of algebraic structures that could provide cryptographic primitives. And ultimately, not only was it very complicated, it was also so novel that these were well beyond the realm of actual peer review. And to me, what's important is ensuring that we actually achieve these goals. And while these things could end up being very powerful tools, they need to go through peer review. And so I started to refine the idea. I started to shrink into things that people already have, well researched, have been in implementations in various ways, and ultimately started to converge on what Quilibrium is today. And so the approach was to simplify, 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 use peer-reviewed, audited techniques only, launch small, iterate, and unlock transactions once the network is stable, ensure that cryptoeconomic security remains stable with generations of technology, and learn the lessons of other protocols. Boy, howdy, did we find some interesting circumstances when we first tried to launch. So about a year and some change ago, we started with a KZG ceremony. For those who are unfamiliar with what KZG is, it is a commitment scheme that enables you to create a polynomial commitment, or more simply put for non-cryptographers, it allows you to say, I have a lot of data, here is a tiny string that basically says this is proof of the data, and I can use some clever math to prove that I have all of the data and it relates to this. And you can build all sorts of wonderful constructions on top of it, including proving that an application was executed correctly and so on. But you have to actually have what's called a KZG ceremony or a powers of Tau ceremony in order to actually set up what is called a secure reference string. So around April last year, we did the KZG ceremony, and even when I launched the ceremony, it was such a unbounded success in terms of how much attention it got that we had over 200,000 contributions to the ceremony, providing randomness and entropy that helps keep that cryptographic reference string secure. And it immediately knocked us over. I immediately had to fight the fires on that and get it back up. And we ran it for about, I want to say a month and a half, maybe 2 months. And by participating, we incentivized it by giving a voucher that was essentially, you create a private key, which you use to sign your contribution, and then it gets included into the transcript log of the actual ceremony. And by doing so, you get... Yeah, exactly. I know, right? So it gets 50 quill per voucher, and at the end of the day, when everything is launched, you were able to claim those 50 quill tokens. So after we did that, we then actually tried to go forth with launching the network. When I began that process, we immediately were again met with more surprises. Not only did we have a lot of interest, we had a lot of people with Kubernetes farms ready to go, and we got hit with over 400 nodes, which was astounding to me at the time because, like, there's very few networks that even have that many nodes that are actively participating, and to see like 400 slam on day one was unexpected, and it immediately stress tested the network. So we had to learn a lot of lessons and build on top of that and move forward from that. But before we get too far into the actual stages of development that happened from that point on, I also want to answer a few questions about what were the lessons of those previous networks? Like, what did Ethereum, what did Bitcoin, what did Solana, what did they all do, and what were those statements that people made, those observations that were making it hard to use, that were making it hard to scale? What were the problems? What were those lessons that people have said that they've learned from those networks and are working towards to solve the problems of those networks? And it always came down to things like, we need better tooling, we need better infra, the UI just needs to be improved, or gigagas as a new term that's been coming out, or the idea that proof of work was inherently wrong, has diminishing returns, proof of stake is better, or just generate and manage the wallets for the users so they don't even have to think about wallets. But in reality, these were actually just describing the problems, but they weren't actually saying the solutions. And so a couple months ago, I gave a talk at Coinbase, and I also gave that same talk at a condensed version at the FarCon conference, where I talked about the structure of network designs like Ethereum and the iterations they went through, this being ETH 1.0, this being the structure ultimately of ETH 2.0, and then with the addition of L2s to increase the scalability of the overall Ethereum ecosystem. I made an observation casually that it kind of looked like the Commodore PET and had roughly about the same performance. The other lesson I also wanted to point out was around the proof of work. And one of the things that a lot of people don't know, especially if you weren't there near the beginning, there's been this kind of behavior in cryptocurrencies where a lot of new protocols come out, and sometimes it's because it's not really built by people who have done cryptography before. Sometimes it's because they don't want to stray too far off the beaten path, but they end up building these kinds of structures that are basically mimicking what's already out there. This process is often called cargo culting. And this is finally starting to show the consequences of cargo culting by design. So what is right here is a graph of the miners' revenue of Bitcoin. One of the things that Satoshi Nakamoto, if you've seen any of the past conversations when Satoshi was still active, had mentioned very offhandedly was that upper limit of 21 million Bitcoin was effectively a kind of a guess, just kind of a casual guess. A casual guess that has been replicated in other protocols, putting flat, issuance curves that have an intrinsic limit. Just that structure has been replicated and copied over and over and over and over again. And now we're starting to see what happens when you reach the endpoint, because we have finally hit another halving for the network. In this graph, I've posted snippets of ever since I started to notice the trend happening, but I keep posting it about every month or so because it keeps proving my point that things are getting worse. Essentially, what happens when you have a flat issuance curve is that inevitably, as you get closer and closer to the end of that issuance curve, you hit this intrinsic variability where transaction fees are insufficient alongside the actual emission rate of the network, such that miners become disincentivized and will start dropping out. And the ratio that we're looking at today is one where Bitcoin has a price that is insufficiently high enough to reward the miners to continue to keep operating. There are miners that are now shutting down. And what happens when you have like this tremendous hash power behind something like proof of work, you end up with a scenario where you start to lose some of that hash power and it becomes reserved, tossed over to other networks, or simply just discarded. And when you have that happen, you end up in this state where what is called cryptoeconomic security of a network becomes threatened. Because one of the core attacks, one of the core problems with proof of work or schemes very similar to it is what's called a 51% attack, which means that if somebody controls more than 51% of the mining power of the network, they can rewrite history. And we're reaching a point now where the miners' revenue is getting sufficiently low and miners are starting to drop out, that if the hash rate continues to trend downward, but all that hash power remains still in existence somewhere, you now have the possibility, not necessarily the actuality, that a 51% attack could be conducted on what is considered the most valuable crypto asset so far. So proof of work's got some issues. Flat issuance curves that have a limited cap have issues. Proof of stake has its own issues. I'm not even going to dive into that can of worms right now. These are problems and lessons that we had to learn from. So how did we take these lessons and apply them into Quilibrium? I'm going to dive into that in just a sec, but I have seen a lot of questions pop up, so I'm going to go ahead and take a look, because I am actually, for those who don't know, I'm simulcasting this. I'm doing this on Twitch and doing this on Lonely, so I've got 2 different chat logs I got to look at real quick, but I want to make sure I'm not missing anything along the way. Okay, cool. Yes. So one of the things about that deployment script for testing, and I'll get into that, was just I didn't have a flag set correctly, so it basically kicked off a bunch of extra tests because it thought that it hadn't fired off, and that just, God, that was an expensive bill. Anyway. So ultimately the answers to those lessons, we need better tooling. No, we need a better dev environment. We need better infra. No, we need a design that doesn't centralize indexing. The UI just needs to be improved. No, we need actual abstractions that are baked into the network design that are actually skeuomorphic. For those who don't understand what skeuomorphism is, if you remember the old days of the iPhone, the very first iPhone apps that came out, they were all skeuomorphic, which just means that they replicate things that existed before. So if you had an app that listened to radio, it looked like one of those old school radios with a dial, and it was kind of cool looking. You also had really pointless apps where people could fake drinking beer and stuff, but at the end of the day, they all looked kind of like the real world equivalent that this digital replication is providing. And when it comes to crypto, we did actually have a skeuomorphic abstraction at the beginning. The very first crypto network that existed, Bitcoin, was a decentralized ledger. That's it. It was just a ledger. And so what we've done since then is just extended on top of a ledger, but not actually created an abstraction over generalized compute instead. And so this weird hybrid bolt-on thing that happened with a ledger is very far beyond anything that is actually skeuomorphic. So you don't need to improve just the UI, you need to improve the network itself. And then of course things like gigagas. I've got some very strong opinions about that, and I could probably spend an entire hour talking about it, but no. Proof of work has diminishing returns. I actually kind of disagree. It's not that proof of work has diminishing returns, it's that we need a better form of proof of work, not proof of stake. And of course, just generate and manage wallets for users, that other lesson. No, we need to rethink that, and this comes back to the skeuomorphic abstractions problem. Why use wallets at all? And so I'll dive into what all that means and how all those lessons accumulated. So, what did that all lead to? December 25th, 2022, I published the original Quilibrium white paper. Boy howdy, I do not like LaTeX. LaTeX has never been a friend of mine when it comes to writing papers. Historically, I've struggled with it, and if I could have avoided it in the first place, I would have, but honestly, the white paper's hard to read. I agree. There's a lot of people who said that it was incomprehensible. I wouldn't say it's incomprehensible. Where it's really rough to read, I did make references to the papers that I was building on top of, so you could see far better formatted versions. But if you're not a cryptographer at all, even then, it's still very, very hard to read. So I do, once 2.0 comes out, I do want to have a better, easier to read white paper. But yeah, I agree. It's pain to read. But what I was trying to answer through this white paper was, how do you actually architect a different form of network that isn't a distributed ledger? Instead, it's a different kind of distributed compute system, something that is forming around a different object for consensus than a distributed ledger. How do you achieve the same principles of general cloud compute, but in a distributed, private, secure context? And so we started. As I said, I launched the first phase of the network. We ended up with 400 nodes to start off. Everything crashed. It was a big chaotic mess. But over time, I started building and solving those problems as they arose, and we ended up with some of the core components that ultimately became the basis of Quilibrium. And then as I have up there, we had like 17,786 peers, which was still insane to me at the time. I thought that was quite absurd, but what I realized is show me the incentives and I'll show you the outcome. Because it was an incentivized testnet phase of the network, people ran nodes. Even if they couldn't necessarily use those rewards yet, people ran nodes, and boy, did they run a lot of nodes. And so we got past that point. We started to move into the next phase of the network, which is the dusk phase of upgrades. And this is what we're currently within. And those components that we're building on top of from the original Dawn part of the network essentially turn it into that decentralized cloud platform. And so far, we've had over 250,000 reward peers. The highest peer count we've had was over 200,000. Thankfully, that shrank a little bit, so it's been a little bit easier to manage. Some of those peers, we've had some interesting issues trying to deal with Sybils. Long story, best left for another video. But ultimately, we are getting closer and closer to the point of 2.0 being ready to go. So, where do we sit today? Today, the network has thankfully shrunk in size, but there's a little asterisk there. The latest count was roughly around 29,000 live peers. But one thing I noticed that is unique from our previous stats, where we were sitting around 200,000 peers, is that they were at about roughly an average of 11 cores a node. Now it's about 48 cores a node. What does that mean? It means one of two things has happened. People have either consolidated multiple nodes into a larger, more powerful node, or they are actually running in what we've supported as a clustered mode. So if you were to try to translate that to the equivalent of the types of nodes that we're running in the Dawn era, we're actually sitting at around roughly 125,786 physical nodes. But in terms of peers on the network, it's about 29,000. That's actually a nice thing. The more that we have as logical peers is actually better, because it means less traffic has to actually go over the network in order to fulfill the objectives of the network. So, finally, time for the deep dive. Structurally, we have a very different design from other blockchains. In fact, that's why there is the running, not necessarily a joke, but the running statement that I have iterated over and over again that we are not a blockchain. What the network is effectively creating is something a bit different. I've used the term historically of an oblivious hypergraph, and ultimately that has been memed to hell and back because it is a very obscure construct, both in the terms of mathematics and cryptography. So since then, I have just instead called it a distributed network, and you can treat this as a distributed database with compute. That makes things a little bit easier for folks to grasp. Let's see. Okay. So, we have gotten to the point now where we are reaching the finalized launch of the network. So let me, of course. Okay. So let me get into the launch steps side of things. We were originally rolling out 2.0 in July, and we've done a lot of tests, and it was said up front that, this is going to be a measure thrice, cut once kind of ordeal, because once we have fully launched this network at the 2.0 phase, there is no going back. And we've found a lot of different things along the way that have been very important in terms of keeping the network secure, increasing performance, finding any sort of deficiencies that could be improved upon. And ultimately what that has resulted in is an extremely efficient network. So for those who have been in the P2P oriented space for a while, you're aware of some of the similar libraries for peer-to-peer communication like GossipSub. We have a forked variant that has been forked and modified so much at this point that it no longer resembles GossipSub at all. It is called BlossomSub. Let me see if I can get this chat pulled up. This is getting a little bit difficult to juggle. Okay, cool. So we have actually gotten to the point now where we have forked practically all of the components of the libp2p libraries that we use. And a lot of this has drilled down into performance. And you can see some of those characteristics and the changes that have happened. So people have been wondering, like, what's been happening behind the scenes? I mean, the code has been up there. People have been able to actually see what's been going on behind the scenes. But for people who are less inclined to actually review the code, I can at least illustrate some of those changes that have happened. So, for example, we've had instances where we found that the use of defer in Golang is actually slightly slower. It causes different penalties in terms of performance compared to actually just taking whatever that deferred statement is and issuing it at a time that is sufficiently safe to issue. And so we've actually achieved performance increases to the point now where the network is capable of handling a load of over 100 million messages a second. Now, messages aren't transactions. I want to be clear about that. But there are a lot of applications that are message-only oriented. You don't need transactions in terms of actual data settlement to still be useful. So being able to support over 100 million messages a second as a base case is something that immediately unlocks many, many, many internet scale applications to run on the network efficiently. That is already monumentally better than what exists. A couple of other things that we have done is also fixed some really weird broken things in the Go multi-adder library. Is this the change set that has it? I'm not sure if it is. Like you can see, I have changed a lot in these. But essentially what has been changed is in these libraries, they make a use of what's called the defer, panic, recover pattern. Instead of actually tossing an error back when an error occurs, they just panic, and then the outside calling function will just defer the evaluation of it such that if there is a panic, it catches it and then it returns an error. Even the developers on those projects have actually listed as issues historically that these are things they needed to fix. But the problem is that the only way to fix it is to break the interfaces of those particular libraries. So, like I said, these are forked so far beyond what they previously looked like that we actually have to maintain a wholly separate fork of the GoLib P2P stack. And it is an enormous amount of code changes. So those are some of the changes that we've done along the way in terms of getting to 2.0. Couple of other things that have come up is getting the performance of some of our other libraries up to par. So we have translated certain things into Rust. For example, our random permutation mixnet that provides unlinkability of sender and recipient for messages on the network. We have done a lot of performance drills that have increased the performance of this such that we can actually securely mix, millions of messages without any impact to the user experience. Like it basically can just run in real time. And so finally, that leads us into the most pernicious part of the network, which is how we do secure evaluation. And so this is the last thing that I wanted to talk about before we get into the Q&A section. So a couple days ago, I posted what was going on with the final delay in getting 2.0 out. And essentially what this amounts to is we have this way that execution on the network works. Essentially, in other cryptographic networks, think like Ethereum, for example, you construct a transaction, you sign the transaction, you submit the transaction to the network, it ends up in the mempool. Some prover or some block proposer for the network will propose a block that includes the transaction if it's valid, and then it ends up incorporated into the blockchain. Quilibrium works a little bit differently because all of these shards are individually holding different transactions that relate to their shard only. And so there's a slightly different prover basis. It's sharded out. There's very few networks that do this. So structurally, if you just want to kind of limit your scope in how you think about it, if you want to think about one shard as like a miniaturized kind of blockchain, you can kind of do that. I don't like that because it's not really a blockchain, but if that helps you understand it a little bit better, basically it's that. So the way that we provide privacy on the network for low-powered machines is that the network is an MPC network. So in other words, instead of networks that have privacy through the use of zero-knowledge proofs explicitly, we do interactive zero-knowledge proofs through the use of MPC. And the way that zero-knowledge works using MPC is this process called MPC in the head. MPC in the head, if you're unfamiliar with it, or if you're unfamiliar with MPC altogether, multi-party computation lets you take different inputs from different people and perform arithmetic operations over it securely such that no party reveals their private inputs to the other side and you get some end result out of it. MPC in the head is where either in the case of the offline prover model, they will basically run both sides of that MPC arrangement. They will then basically take an execution transcript. So I wrote down all the steps of what I did, And then they perform an operation over that basically compacts it into a smaller size that is sufficient enough to convince the network that what you did was correct, such that it can be accepted in the final state of the data that you're settling on the network. But recall, the data on the network is encrypted. And so in order to do that, these circuit sizes can get quite big. But what's problematic is that the circuit sizes being big means that the bigger the circuit, the bigger the proof. And the way that we use MPC in the head is we don't currently have a means to reduce the size of that proof. So historically, what we were doing is to, obviate this problem. We would take the size of that proof in conjunction with the size of the data that is settled for all the transactions on the network, and that collectively created the overall size of the network's ultimate state. What's important about that is, as I said previously, learning the lessons of proof of work, is that you have to have some sort of function that limits issuance, because if issuance is completely unbounded, then there is no actual cryptoeconomic incentive for people to operate nodes. But if you also make it such that that particular cap is derived from the storage state of the network, someone could theoretically issue a bunch of really big transactions that would condense to the point where the network is now so full of data that it no longer issues tokens. So we had two basic ideas in principle that made that harder to do. The first is that data costs money. The second is that we take the overall generation of compute speed and use that as a generational basis for determining how fast the network is operating, so that we know what era of compute we're effectively in. The idea that Moore's law, that ultimately computers get faster and faster over time, we use that as a measurement to determine when the next unlock window is to start issuing more tokens. So what happened is, with this ability to do MPC in the head, is there was a form of construction you could create that would actually generate very little data, so it would cost basically nothing. And by consequence, costs barely anything, but the proof is very, very large. That still counts towards the total state that results in the issuance curve being limited. So an attacker could theoretically not necessarily fully stop issuance, but reduce issuance to practically the point that it is no longer useful to operate as a miner on the network. And so that form of attack was the most critical thing that we had to stop. And that's why we've had to take a moment to sit back and rethink how we are actually doing this particular portion of the network and make some changes in order to actually get this out the door so that 2.0 can be safely launched. So there were a few options that we looked at. The first was trying to use an alternative offline prover scheme. Ultimately, there were a few out there that were pretty solid, like RISC-0 and SP1. The problem is, to give you kind of a comparison, if you know the speed of a SHA-256 hash, obviously it's quite fast, but if you were to do it over MPC in the head, it's a matter of like 7 milliseconds. It's very, very fast. If you were to do it on RISC-0, it's seconds. It takes seconds to execute that proof. And SP1 was still seconds. It was nowhere near the speed that MPC in the head works at. So then option 3 was, okay, we keep the full prover system as is, and then find a solution to reduce the size of the proofs by finding a recursive compression technique. That would be, of course, way better, but there is zero literature on actually doing this yet. Solving it would be greenfield and not peer-reviewed. And again, as I said at the beginning, what we did when we designed the network in its current iteration is it must be peer-reviewed. We cannot use things that are so net novel that there is no way we can be fully assured that this is a safe thing to do. So now we are finally in option 4. And so option 4 is to impose a transaction fee system, and the way we do that will be different than the current one. Essentially, the way that things operated in the current design was that they're essentially optional. Provers could choose to accept a transaction without a fee because they are data greedy, that they want to store as much data as possible, they want to prove as much data as possible to gain the greatest rewards as possible. The problem with that is that if a prover was to be malicious, they could actually start proving over very large sets of data that they are intentionally compressing large amounts of proofs into in order to get the issuance curve basically to nothing being issued thereafter. So instead, we're having to revisit the actual transaction fee system so that instead of it being an optional layer on top, it is baked into the actual execution of the transaction itself. This is kind of painful. So that brings us to finally the question of when. So for the folks who I've talked to obviously more frequently, they've already heard we've discussed about like what the impacts are and what the ramifications are and how much longer is this going to take. I feel very confident that we will get this done before the end of the month. We are so close to this being completed and so close to 2.0 being out. We will get it done before the end of the month. But that means that it's still going to take a little bit more time. We have to be sure. We have to be careful. That is why we are saying end of month. It might be sooner, but I want to set people's expectations safely so that people don't feel like they have been misled or anything, because this is a very critical piece of the network, and it is being tweaked in a way that has not been tweaked before, at least in the most recent generation of the network. So by doing so, I am putting a firm statement. It will happen no later than the end of the month, but it might happen sooner. So that's where things are at. That being said, we are now at the point where people are free to ask questions. We have got 2 different chats open for Unlonely and Twitch. So if you've got questions, let's go. Okay, yeah. So monitoring network admissions. I'm so sorry, I forgot to mention that when we got to the slide about the number of peers on the network. So I am. One of the things that's actually been really interesting, if you watch your logs enough, you'll start to see a certain pattern that's occurring. There has been a number of people who are not maintaining their nodes correctly. It's getting to the point now where most of the messages that are passing over the network are from peers that have not updated their nodes. So while, yes, there are more powerful nodes on the network, and it is possible to swap to a larger, more powerful node in order to gain more rewards, the rough estimate from the actual, most up-to-date, actually correctly running, once you get past the 700,000 iteration mark, we're actually still within the emission curve. So far, so good. And by the time we reach the end of the month, we'll still be within safe boundaries. So yes, I am monitoring. So far, we are okay. I know that some people are taking advantage of that, and I can't blame them, but we're still safe. Cool. Dang, I really thought that there might be more questions. Oh, yeah. Prover rings. Okay. So Prover rings, for those who have heard some of my streams before, you may have a vague idea of how Prover rings work. So essentially let me actually bring up where are you? I might have closed it out, one sec. Okay, cool. So the structure of the network itself is sharded. Like I said, there's essentially 3 tiers of shards. This kind of illustrates how that works out and what the actual structure is in terms of logical components that builds it up. Each one of those shard levels has its own ability to be a prover ring. When the network first starts out with 2.0 launch, we're basically assuming that the network will converge on the highest layer. So you can think of it kind of like a tree. So there's essentially 256 global synchronized commitments or global shards. And then from each of those, there's 65,536 core shards. And then inside those core shards, there's the actual data blocks. And each one of those layers of that tree can have prover rings around it. But the deeper you go, obviously, the more rewards you get, the deeper you go, assuming there's data to actually prove over, which is why it incentivizes network growth and people actually providing, the greatest range of replication. But essentially the way that it works is kind of a queue system. Let me get back to there it is. Okay, cool. So basically what happens is at those different tiers, at the highest layer of the protocol, the only messages that go over the protocol are essentially these commitments for the global shards, which is why we're able to I will answer that question in just one sec, sorry. So the global shards basically have 19 kilobytes of data in total for all of it. for all 256 shards. So there's very minimal traffic that goes over that channel. And so when any node is trying to declare a membership of the prover ring on that, it's another message that goes over that channel, but it is essentially prioritized such that it is based on seniority effectively. Like the longer you've been participating in the network, the higher your essentially your message is prioritized when it's being included in the set of who is in the prover shard or prover ring for that given shard. And if you choose to fragment, basically like a given global shard has become too large, then when it fragments, you can actually get the same level of priority in choosing out which shards you want to cover. Let's see. Okay, so something about the bridge. I've seen people ask that too. I have to be very specific about how I answer that question. As I said at the very beginning of this, there are certain things that I'm not answering. But we do not have any intention of opening the bridge until 2.0 is launched. On top of the fact that it actually would be deeply complicated to do so, it is also a matter of principle in that like we've got basically 0.17 and 0.18 of like the interval of time in which proofs were not bridgeable. And we announced well in advance whether or not tokens were bridgeable then. All right, putting cart before the horse. What sort of engagement is being pursued with potential app devs? There's quite a few. I cannot announce those yet, but yes, there are individuals that are either actively building or having plans to build on, depending on the availability of the things that they need. We've got a few things that, in principle, essentially they'll be able to jump onto once 2.0 is launched. Basically, our S3 compatibility and our KMS compatibility. Can't wait to announce them, but can't announce them yet. Can we continue to cluster 2.0 or when 2.0 launches, assuming our machines are the same spec and meet the requirements? Yes. Yes, you can continue to cluster. Clustering is expected, probably deeply encouraged, just given the amount of problems that we dealt with when it was way more logical nodes, so to speak, that were shuttling over the network. Okay, yeah. All right, let me double check the other avenue. How will newer nodes be introduced into prover rings? Same way as everyone else. So when a node joins the network post 2.0, there's essentially an announcement that says, this is my node, this is my peer ID, these are the capabilities that my node can offer, these are the specs that my node can offer. And then it makes a declaration of, well, first it queries the network for what is most like in need of coverage, because the default mode of a node, like there will definitely be forks where people will go into specialized modes that are seeking different crypto economic incentives. I'm not diving into that, but our official node client is going to be data greedy. And so the idea is going to be providing the greatest replication at the greatest ability for it to do so. And so the focus of the node will be declaring like, these are the particular shards that are not replicated the most. I'm going to target those, and I'm going to announce my intention to join the prover rings for those. And then when those get included into that particular level of shard basis of the network, was when they'll actually be accepted and inducted into the prover ring. Increment plays into that as part of the whole seniority thing. So in other words, the greater the increment, the greater the seniority effectively in terms of the .19, .20, .21 context. Before then, there's also like historic nodes that have been in different generations of the network since the beginning of the dawn phase. So that also factors in terms of overall seniority. And also it factors in terms of lack of seniority. So in other words, there's a penalty by leaving the network. One example of this would be, I've been running nodes since all the way up to like .18, and then I stopped running a node. I didn't run for .19, .20, .21. I have no increments that can be contributed as proofs to claim there. That actually does impact your seniority because you have now reduced the amount of time you've been participating in the most recent iteration in the network. So the seniority factor is something that is always trying to ensure that nodes stay online as much as possible. You can kind of think that as the, trying to remember the name of the penalty for Ethereum. There's it's not a slashing penalty. It's like an inactivity leak. Basically, that same kind of construct. So there is a case to be made for just starting a new node. Yeah, I mean, like you can always start a new node. It's just that your seniority is now 0. Like you have no age on the network, and so the in terms of priority for inclusion into prover rings, that would be prioritized the least. But if you're the first one, in that given prover ring, then that doesn't matter. It just means that when everyone is submitting messages competing in order to get included in priority for that ring, yours would be prioritized the least because it has no age. How does this latest shake transform Q and the perspective you have had of its capacity? None. That doesn't change capacity at all. The only thing it does is it changes the crypto-economic basis on which that capacity is disincentivized. Because like some people have drawn attention to before, like when it comes to storing data on the network, how it impacts the overall issuance curve. A malicious operator could just store a bunch of stuff and that would decrease the issuance, but that costs money. Whereas before, we weren't including proofs as part of that, and so by consequence, including proofs in that now and also forcing transaction fees to be required, it is now essentially a forcing function that prevents somebody from adversely acting in such a way that would do that, because they would be disincentivized because they'd actually be spending more tokens than they would be earning by, or not earning, but I got to be very careful about the word there. Basically, it's a crypto-economic incentivization. Do we have an idea of minimum upload rate in megabytes for those of us using running multiple home nodes so we can upgrade our internet if needed? So the way that we use MPC, if you are running on a low speed connection, you can basically operate in just a replicating prover model. Like you can take offline proofs instead of having to do interactive MPC, because an interactive MPC uses a lot of bandwidth. It's roughly capped at around 50 megabits per second. That's basically like the peak optimization. Like past that, it's diminishing returns in terms of performance. So if you don't have a good connection, you can run your node without actually doing the online prover model. You can just be strictly offline prover plus data prover. Are you experimenting with CUDA support yet? Not yet. That was one of the interesting side effects of investigating some of the other offline provers, is that technically they already have CUDA integration, and that would have been really cool, but they're just so slow. They're so slow, even with CUDA. Does this new fee update affect the streaming video estimate release date? So we're trying to get 2.0 out as fast as possible. Any further upgrades to the network that would happen thereafter are going to have their own ETA adjustment that follows. It's just the consequence of these things happen incrementally. So I will give an updated ETA once we have gotten through that part. So stay tuned. End of month is the most important period of time that we are looking forward to right now. Everything else will have adjusted timelines accordingly. What sort of penalty on seniority? Oh, wait, shoot, I'm reading this out of order. Okay. For instance, I ran nodes for .18, .19, .20, and then I stopped the nodes. The backups were made improperly, so the network would not perceive, or so would the network perceive that as absent or just not claimed? Well, .18, if you showed up, that would have been included. But .19, .20, .21, if that's what you meant, it would be, yes, perceived as absent. The trade-off there is that the deeper your seniority goes, like if you've been there since the very beginning of the Dawn era, that's still way more valuable than not being present for .19, .20, .21. What sort of penalty on seniority and or priority takes place for nodes going offline now that have been consistently active since 1.4.18 or throughout 1.4.19 in practical terms? You know what, I will publish a full response to the mathematics of that on the PSA post here. so that people have a better understanding of that and can calculate accordingly. Who is we? How many fellow engineers do you have working with you? Any Farcaster devs? Um, oh, yeah. Who is we? There's a few people. I am being a little bit vague in terms of saying who these people are because there are certain individuals who do not wish to be identified as working on Q right now. There are reasons why they would not want to be, and I'm respecting their privacy on that. In terms of dedicated people, like people who are strictly on the project, obviously the one with the greatest commitment is myself. For the person who just asked when 2.0, please rewatch the stream. All right, so if there are no additional questions, then we can go ahead and wrap it up. Cool. All right, thanks everybody, and yep, soon, soon, very soon, very, very soon. Yeah, so I appreciate that. I really do. I really do. Like the support that I've gotten from a lot of people means a lot to me. It really does. I know that there are some people who are upset. You can't make everyone happy, but the one thing I'm not going to do is make a decision that would, threaten the integrity of the network. Hands down, the mission is more important than anything else. And sometimes the right thing is taking the extra time. We've actually seen a lot of networks in recent history that have had, fully audited code bases that have had, roughly tens to hundreds of millions of dollars in tangible value on those protocols that have been hacked in recent history. Blindly rushing through something just to get it out the door because people are, some people really need this to be out there for whatever their particular reasons are. That's dangerous. That's really dangerous. And the consequences would be far worse if something went wrong. So we are looking forward to this being at the latest at the end of the month, possibly sooner, but we are setting it to the end of the month just so we, don't make people feel like things are getting pushed beyond a limit that was stated otherwise. So look forward to the end of the month, and thank you all for watching. Okay, sorry. I will take a second to laugh and acknowledge that one. That I remember how long ETH 2.0 was delayed. Yeah, we're not taking 6 years. So, yeah. Thanks for that. All right, thanks guys. I will catch you all in the next one.